Okay, so this is the first video about the algebra review. We're going to talk about solving here. I am going to upload the notes that I'm using here as a PDF. So if you want to download those or print them off, and you can pause the video periodically to try them on your own, or you can just follow along. Whichever you want to do is up to you. So we'll see how this goes. First of all, in general, I want to make sure that we understand the word solve. Solving means finding the value or possible values for the variable that makes a statement true. Okay, whether that's an equation or an inequality, we're looking for any possible values that make statements true. Now, the ones that we have here are all linear. That means that each variable only has one possible value. It won't have more than one possible answer. But the general word solve means there could be more than one. To review, order of operations, we generally remember this as PEMDAS, or please excuse my dear Aunt Sally. Oh, let's see, there we go, there's the pen. Okay. What I want to stress, though, is that it's not, like P is not just parentheses. We say that because it's easy to remember, but parentheses includes any type of other grouping symbols as well. For example, if you have a square root that's got multiple operations under it, then that square root is also a grouping symbol. And another important one is a fraction bar. If we have a big fraction bar where in the numerator or denominator there are other operations, it still counts as a grouping symbol. So I'm looking down at this example here. Okay, this fraction bar would fall into the same order where the parentheses go, not with divide. Okay. Okay, and then exponents, radicals are also exponents. We won't do too much of this year, but as you move into Algebra 2, you'll start seeing roots expressed as fractional exponents. So the square root of a number is the same thing as that number raised to the 1/2 power. So exponents and radicals go together, and again, we're not going to have a ton of those. Multiplying and dividing go together from left to right, not multiply first and then divide. And then same thing with addition and subtraction. Those two are grouped together, and we move from left to right with those. Okay? Properties of algebra. The general rule with algebra is if you have an equation, whatever you do to one side, you have to do the same thing to the other in order for the equation to stay true. Okay? So we could add the same thing to both sides of an equation. So that would be the addition property. Okay? We could subtract the same thing from both sides. That would be the subtraction property. Okay, we can multiply both sides by the same thing. Now, when we multiply, we do need to distribute. We need to make sure we multiply every term on both sides of the equation by the same value. So that's the multiplication property. And then lastly, the division property. The last of our 4 standard ones is the division property. We do specify we can't divide both sides by 0. Okay, but you shouldn't have to anyway. And then the other one that doesn't quite fit in with either of those is the distributive property. And the distributive property comes into play when we have parentheses. Okay, and I'll go ahead and write that one out. So if we have, now A, B, and C here are all numbers. Okay, if we have some value that's multiplied by something that is inside a grouping symbol, like the parentheses, then we take whatever is on the outside and we distribute it. We multiply it by everything that's on the inside. So this becomes A times B plus A times C, whatever those values happen to be. Okay? All right, so let's go ahead and look at some examples here. The general rule with solving algebraic equations is we want to try and get the variables all grouped together on one side, and then we go through the order of operations backwards to try and isolate that variable. Okay? Now, sometimes there's other things we have to do just depending on how complex the problem is, but that's our general idea. So I'm looking at this first example, and I see that there's an R on the left and there's an R term on the right. So I want to get those on the same side, okay? And it doesn't really matter if you go to the left or right. Some of you have learned to always move your variable to the left, and some of you have learned to move your variable to whatever side gives you a positive variable coefficient, but it doesn't really matter, okay? To get the R's together, though, we do need to take care of these parentheses here. Okay, so what we're going to do first is use the distributive property and multiply the -3 by both terms on the inside. Okay, and as I solve equations, I am going to write the entire equation, not just the right side in my next step, because I want to use correct math notation and complete math statements, not partial statements. Okay, so even though I'm not changing the left side, I'm still going to write out what's over here. So 17 plus 8r, and then now multiplying, I have negative 18. Negative times a negative becomes plus 15r. Okay, and now I'm using my other properties, my addition and subtraction property, to get the variables on the same side. So I'm going to subtract 8r from both sides. I'm also going to go ahead and add 18 to both sides. If you want to do these in two separate steps, you can. If you want to do them in the same step, you can. It's up to you how much you do at once. It's more important to me that your answer is accurate than it's maybe the fastest way possible. Okay? And it also doesn't matter if you write down what I just did. You could leave that blank. You don't have to write what you were doing to move things around, just as long as you are showing some work. Okay, so left on the left side, I've got a 35. That's gone. Equals, this is gone, 15r minus 8r, 7r, and then we use the division property because this is multiplication. Divide both sides by 7, so r equals 5. Okay? If we want to check our answer, we can always take that, plug it back into both spots where the r occurs, and see if we have a true statement or not. If we do, then our answer is correct. Okay? All right, moving on to the next one. Again, at any time, if you would like to pause this and try them on your own first, you are welcome to do that, and then just resume when you are ready. Okay, for this one, I'm going to start by getting rid of this 2. Okay, this is being divided, and even though in the order of operations, if I were going backwards, I would look at addition and subtraction first, because the fraction bar here groups the m plus 4, kind of like invisible parentheses. I'm not going to take care of that until after I get rid of the 2. So to get rid of that 2, I'm going to multiply both sides of my equation by 2. That cancels out. I do not distribute the 2 to the numerator because there's no 2 left. That 2 was canceled with the 2 that was in the denominator. So all that's left on the left is m plus 4, and on the right, negative 6. So then we subtract 4 from both sides. M is negative 10. Okay. Next one, I do have a mixed number here, and you will soon come to find out that I do not like mixed numbers at all. I'm going to change sorry, interruption there. I'm going to change all of them into improper fractions. So I'm going to start by multiplying the 2 times 3 and adding the 1 to make this 7 over 2. And I don't want to rewrite the whole thing just yet. Okay, so I'm going to add the negative 1 to both sides. So I have 7 halves x equals, and then if I'm adding 1 to this, I need to think about common denominators. So I'm going to ask myself how many fourths are in one whole, and there are 4 fourths. So this is actually like adding 4 fourths. Negative 11 fourths plus 4 fourths is negative 7 fourths. Okay, and then from here I can do this in 2 steps where I multiply both sides by 2, then divide by 7. Or I can divide both sides by 7 halves, the fraction, and to divide fractions, we multiply by the reciprocal. So I'm going to multiply times 2 sevenths there, times 2 sevenths here. All of that cancels. Okay? And over here, this is also something you're going to hear me say a lot. If possible, reduce your fractions first. Those 7s cancel out to be 1s. The 2 and the 4 I can reduce to a 1 and a 2, so all I have left is negative 1 over 2. Okay? It wouldn't hurt to do negative 7 times 2 is negative 14 over 4 times 7 is 28, and then reduce both of those by 14. But I'm always looking to make my numbers easier first. Okay? All right, looking at this next one, I've got a lot of fractions. I do see one mixed number. This one I'm going to change first, so I'm going to make this 13 fourths. Okay? And now I have a couple of options. I can decide to take care of the parentheses first. I can start moving terms around, or I can try and get rid of all of the fractions first if I want. Okay? A lot of times it's easier for us to operate without fractions. So to do that, what we need to look for is the least common multiple, or the least common denominator. Okay? So what this means is what number will all of the denominators and the individual fractions go into? What will they divide? Okay? So the smallest number divisible by 8 and 4 and 2 is 8. Okay, I don't need to multiply those together. They all go into 8. But then I also need 5 to be a factor. So my LCD is going to be 40. Okay? The way I use that is I'm going to multiply every single term by 40. And if I do it correctly, it should cancel out all of my fractions. Okay? So, to remind myself to hit every single term, I'm going to put a 40 next to everything. Sometimes we remember to do everything on one side but maybe forget the other side, so it really helps to write that down. Okay? Now, if you notice, I did not put a 40 next to this -2. The reason I didn't do that is because I have a 40 on both of the terms inside the fraction. And if I have the 40 by both of those terms, and I multiplied the -2 by 40, then I would actually be multiplying both of those fractions by 40 twice. In other words, I'd be multiplying by 40 squared, 1600, instead of 40. So I'm not going to multiply twice. If you want to avoid this, if this is confusing, you can always distribute the -2 first and then multiply both of your remaining terms by 40. Okay, so going back through and multiplying everything times 40, again, I'm not going to do 40 times 49. I'm going to reduce 40 and 8, reduces to a 5, so I have 5 times 49, okay? Now here's a mental math tip. There's a couple of ways to think about doing this without a calculator. One way is you could do 5 times 50, because that's very close to 5 times 49. 5 times 50 is 250, but we have one less group of 5, meaning we have 245. Okay? Another way to think about it, and this one works all the time, if you want to multiply a number by 5, that's the same thing as multiplying by 10 and dividing by 2. And the reason I say that is because it's very easy to multiply numbers by 10. All we have to do is stick a 0 on the end. And it's also pretty easy to cut numbers in half. So if I'm multiplying 49 times 5, in my head I can think 490, and then I can cut that in half. Half of 400 is 200, half of 90 is 45, and I'm back at -245. Okay? So remember that mental math trick. I'll probably mention it every time it comes up, but it's a good one to help us be faster multiplying numbers by 5. Okay, moving on to the next one, I have 13/4 r times 40, and again I'm reducing those 4s. I'm going to make that a 10. 10 times 13 is 130, and that one has an r on it. Okay? Equals, and then my -2, I'm leaving that one alone for now. Multiplying the insides, I'm going to reduce that by 5 to get 12 times 8. If you are unsure what 12 times 8 is, you can always break that up. Like 8 times 10 would be 80. 8 times 2 is 16, and you could add those together. Okay? That has an r on it. And then 3/2 times 40, again, we reduce, so 20 times 3 is 60. And for the last term, reducing by 5, we have 9 times 8 with an r on it, so 72r. Okay? And then from here, I do need to go ahead and distribute, so I'm going to do that in my next step. Again, I'm writing all of this out. -2 times 96 is going to be -192r. Oh, not plus. Go away. Oh, no, we're not erasing right now. Okay, and then -2 times 60 is going to be -120 plus 72r. Okay, I do have 2 r terms on the right side, so I'm going to combine those before I move things over. Shift this over. So that -192 plus 72 is going to be -120r, and then minus the 120 that's already there. Okay, so now let's see, I'm going to add 120r to both sides, making this 250r. I'm also going to add the 245 to both sides, and negative 120 here plus 245 is going to be 125. And then we divide. Now let's say we don't know what 125 over 250 is right off the top of our heads. Look for other ways to reduce that. Okay, like I know that 25 will go into both of those. If I'm thinking about money, $1.25 is 5 quarters, and $2.50 is 10 quarters. So I can reduce that to 5 over 10, which I know then reduces to 1/2. Okay. All right, a couple more examples here. This one right here is actually has a special name, this type of equation. It's called a proportion. It's called a proportion because it's two ratios that are set equal to each other. A ratio is just a comparison of numbers. In other words, a fraction. Okay? Now, this is going to be a pretty easy one, but one thing I want you to think about is how you can reduce. Okay? And there's a couple different ways that fractions can be reduced, or proportions can be reduced, excuse me. If you have a common factor in a numerator and denominator, like in the 6 and the 2, we can reduce that fraction first. We can also reduce horizontally now in this case 3 and 2 don't have a common factor, but if they did have a common factor, we could reduce that, or the two numerators could be reduced. Now, it's not that we're changing the rules of algebra here, but what we're doing, if we were to reduce the two denominators or the two numerators, would be using the multiplication or the division property, where we're multiplying both sides or dividing both sides by the same thing. Okay? Now, in this case, the 6 and the 2 are the only ones that reduce, so I'm going to reduce that to be negative 3 over 1, or just negative 3. Okay? So I have v over 3 equals negative 3. And now I'm using something that we usually hear called cross multiplication, cross multiplying, but really it's just applying the multiplication property. I'm multiplying both sides by this 3 because it's in the denominator and I want it out of the denominator. So I have v equals negative 9. Okay? Now that's the same thing I would have gotten if I did not reduce first and if I just cross multiplied this way, because I would have 2v equals negative 18, and then I would divide both sides by 2. But again, reducing makes it easier first. Okay, on this next one, here we have two denominators that can be reduced. And remember, it's that we're using the multiplication property, because what we're essentially doing by reducing these is multiplying both sides of the equation by 4. So on the left, the 4 cancels out, and then the 8 becomes a 2. All right, and so now we have x equals 11 over 2, and there's nothing else that needs to be done. We could cross multiply from the beginning, get 8x equals 44, and then divide and reduce, but we don't need to. This brings up one other point. Anytime we have non-whole number answers, that's not a problem. Fractions are better, okay? Try your best to avoid using calculators in general, and leave things as reduced fractions, and again, don't change them to mixed numbers either. They are much better as proper fractions like this. Okay, for this last proportion, we do have a sum and a difference inside the fractions. Remember, the fraction bar groups those together, so I can't reduce the 10 and the 2 here, okay? If the only way to reduce these would be if both the a and the 10 could be divisible or could be divided by 2. Since they can't, I can't reduce that. Okay? So I need to leave that alone. I also cannot reduce the a's from the numerators because those are not factors. They're part of a sum and a difference. Okay? So I need to proceed with cross multiplying, or again, the multiplication property. So I take this entire expression and I'm going to multiply it by 5. When I do that, I need to remember to distribute the 5 to both terms. So I get 5a minus 50, okay? And then going the other direction, 2 times a plus 11 gives me 2a plus 22, okay? From here, I want the variable terms to be together, so I'll go ahead and move them this way. And then I'm moving the constants away from the variables. So I have 3a equals 72 Dividing that by 3, we're left with A equals 24. Okay? All right.